In this lesson, we will discuss differentiation with natural log functions. And we will finish the discussion thinking about differentiation with any logarithmic function. But we'll start with natural log functions. The rule is a very simple one. Here's the rule for differentiating a natural log function. If we're trying to differentiate here, we have the derivative symbol as an operator, and the operand or argument is the natural log of some function. Then when you perform the operation, you get a fraction, a ratio. In the denominator is the argument of the logarithmic argument of your operation. And in the numerator is the derivative of the denominator. So, for example, let's let y equal the natural log of sine of x. Then, if we need to find y prime, the derivative, well, we write a ratio where we put sine of x in the denominator, and then we take the derivative of sine of x and put it in the numerator. So the derivative of the sine is cosine. So we have the ratio cosine x over sine x, which of course, by the fundamental identity, is cotangent. Let's do another example. Let's say we have y equals the natural log of 2x cubed minus 3. And we need to find the derivative. Well, y prime, or dy dx, whichever symbol you want to use, is going to equal a ratio. We take this argument and we put it in the denominator, so 2x cubed minus 3. Then we take the derivative of this denominator and put it in the numerator, so the derivative would be 6x squared. And that's it. Now before we finish, this is a pretty simple lecture, but before we finish, we want to return to a previous topic, implicit differentiation, and use implicit differentiation to develop a similar rule for whenever we're differentiating any logarithmic function. Here we were specifically differentiating a natural log function, and when you differentiate a natural log function, you take the argument, you put it in the denominator, and the derivative of the denominator goes in the numerator. But what about a function that is not a natural log, but some other log? A log where the base is some other number other than e. Remember that a natural log function is a log-based e function, but here we just let the base be anything. Now we'll use our exponentiation to get out of this, and exponentiate, we get b to the y equals x. Okay? Now, we are going to differentiate implicitly in order to find the, to help us get back and develop a rule for the derivative of a log of any base. Differentiating this implicitly, we need to differentiate b to the y, which is b to the y times the natural log of the base. And then this had a y in it, so when you implicitly differentiate, you throw in a dy dx. And then differentiating the right-hand side, the derivative of x is just 1. Now, what we want to do at this point is solve for dy dx. Solving for this dy dx, we will divide both sides by b to the y times the natural log of b. The natural log of b, of course, is just some number, so it's just a constant. So we get dy dx is equal to 1 over b to the y times the natural log of b. Recall that b to the y equals x. So, we can substitute in for this our x. Remember that x is equal to b to the y. So on the next step, we're going to substitute in for b to the y. And we get 1 over x times the natural log of b. And this gives us a general rule for any logarithmic function. If y equals log base b of x, then y prime is equal to 1 over x times the natural log of b. And of course we could generalize this and make this f of x to get and apply the chain rule and get a general rule from when the argument is something greater than x. But we will stop here.